There we go. Like they said, my name is James Baxley, and I'm an open source engineer at the Meteor Development Group. And the Meteor Development Group builds the Meteor framework, which is a way to build JavaScript applications, as well as the Apollo project, which is the goal of the Apollo project is to make it incredibly easy to use GraphQL no matter what you're doing. So if you're using React, Angular, Vue, or just like writing JavaScript apps, or even beyond, we want to make it really easy to use GraphQL. So my full-time role is to try and make it easier like that. So hopefully this talk will help some there. You can find me pretty much everywhere at jbaxley III. I'm a third, so I had to put 3 I's. Okay. That's weird. Okay. Yeah, so Apollo. What is Apollo? So Apollo is a whole different suite of tools that make it really easy to use GraphQL. It wants to take some of the things that can be confusing about GraphQL and make it really, really easy. And then it also wants to try and make it the best experience possible to get you the best performance, the best error handling, the best developer tools, just to make it to where you as a developer can focus on building your product and not have to focus on how to use a new technology. And so we're trying to make that really, really easy to do. We have server libraries, we have client libraries, we have dev tools, we have a lot of documentation. So a lot of our work is just try to make this something that is very approachable and ultimately very, very powerful. So today I want to talk about a subset of that, which is the idea of statically typing your GraphQL app. So who here has heard of TypeScript or Flow? All right, good number. How about Reason? A little bit less. Okay, cool. And then who here has actually used GraphQL, like they're used it at their company or they've used it on a personal project? Nice. Okay, good number. So GraphQL is kind of like set up naturally to work with typed languages like Flow and TypeScript because it itself is strongly typed, which I'll kind of like go over in a few minutes. But it makes it to where you can have a really good fit between your backend and your front end and kind of share all that rigid type structure between all of your code, which will really, really help catch a lot of edge case bugs that I will actually write at some point in this talk. So we'll do some bugs on stage. So kind of what we'll start out is the idea of describing your data in one place. So if you've worked with a lot of REST endpoints or potentially something like Swagger, you know that like you don't really have a good description of what those are. So you have kind of like the whole point of Swagger is to help you document those APIs. And so you as a front-end developer are always constantly like either looking at documentation or running test queries to try and figure out what's there. And but it doesn't really tell you what could be there fully. But with a GraphQL server, you have to describe what your data is going to look like with a really robust type system. And these types will kind of always show you what that shape of the data is actually going to be. And then on the client side, if you use React, which I hope you do because this is React conference, we have an integration that allows you to use Apollo with React incredibly easy. And not too long ago, kind of at the beginning of this year, we rewrote a good portion of that to allow typed languages to gain a lot more benefits and to kind of be able to reach really deep into your application based off of what you've brought from GraphQL. So let's kind of step back and talk about the state of JavaScript as it is. You know, it's like client, server, CLI, oh my, you know, it's kind of anywhere you want it to be, which is really cool, but JavaScript is also kind of a crazy language in that you know, it runs everywhere. So we've got browsers, runs native with React Native or with like Titanium or Cordova. It runs on the server. It runs on the serverless, which, you know, is just a server anyway. It runs on the command line interfaces, Internet of Things. If you can write an Alexa skill with JavaScript and then talk to your like house with JavaScript, which is like scary but also really cool. And then I don't know if you're familiar with a guy named Ken Wheeler. Has anyone here heard of Ken Wheeler? Okay, so he's like a pretty good representation of what it's like to be crazy in America. But he wrote a crossbow that is powered by JavaScript. Oh, thank you. So it shoots arrows with JavaScript that he controls with his phone. So, like I said, it's a scary thing, but it's really exciting. And so if you think about all these places that it runs, then you have to kind of ask yourself, like, how do you actually write JavaScript these days? Do you write ES5, ES6, ES7, ES some other number? Do you write it with Flow or TypeScript? Do you use Reason, which will compile into JavaScript, or Scala or Elm, or literally over 100 other different ways that you can write something that turns into JavaScript? The author of CoffeeScript actually has a repository that lists every different way that you can write code that turns into JavaScript, and it was over 100 ways. So I don't recommend trying all of them, but we'll kind of like stick to a couple today. So with all that flexibility, when you start building an app, you got to figure out, well, how am I actually going to write this app? What am I going to do? And so I want to make a case for using some form of static typing, whether that's Flow or TypeScript, or if you want to like be experimental, try out Reason. And two of the big reasons are a known bug reduction and some pretty impressive development gains that can really change how you and your team work together. So there's actually this study done recently, and this is a link, I'll post this talk online afterwards. This is a link to a formal white paper that analyzed how Flow and TypeScript actually reduce bugs in your app. And it said that conservatively, on average, they can present about 15% of bugs that end up in committed code. So if you could just write JavaScript a little bit different and save yourself 15% of bugs, like, wouldn't you want to do that? That's pretty great, right? And then Reason, which is a project by Facebook that is like an OCaml way to write JavaScript. So it's a functional way to write JavaScript. And they've rewritten their Messenger platform up to 50% right now in Reason. And this is from their latest article. They said they used to get bug reports on a daily basis with Messenger. If you've used Messenger, maybe you've actually run into those bugs. And when they switched over just half of the code base to Reason, since that, and it's been almost a year, they've only had 10 bugs reported. Not like 10 a day or 10 a minute, like 10 total. So that's a pretty massive difference, especially at a platform of their scale. And it's all by adding static types to JavaScript. And then you have the idea of better developer tools. So who here uses Visual Studio Code? All right, it's a great editor. Vim, anybody like me? All right, there's a few of us. It's okay, we're friends. So VS Code is incredible. It's an amazing editor. And it has TypeScript support baked in. So if you're using TypeScript, VS Code just kind of magically works and helps you to make your project better. If you're using a tool like Flow, then there's libraries like Flow Coverage, which will actually tell you how much of your project is actually protected by these types. And so it can help you to find kind of edge cases and missing points that you may have forgotten about. And then both Flow and TypeScript allow you to get the traditional like Visual Studio or Android Studio or Xcode style IntelliSense that can tell you actually like what you should be calling and what parameters and information about these functions, all by just decorating your code with Flow or TypeScript, which really just saves a lot of time. Because if you're like me and you type very poorly and you mistype everything, you get in that process of like type something, save it, go to the browser, realize you like misspelled log somehow, go back, like spell it correctly this time, and then go. And these things kind of help you prevent that. So it makes you more efficient as a developer. So case in point, this is Visual Studio Code, and I've misspelled log. And then it just tells me down here. It says like, log doesn't actually exist anywhere. So maybe you should take a look at that and check it out. This is a tiny example of a coverage report. So it's kind of hard to see, but what it shows you is that this project is a 90% covered in its types. So there's a good chance that like you've handled all of the edge cases of this app because Flow has told you that it's mostly covered. And this is actually some code that I've written, and this is IntelliSense. And so you get a nice little like underline here saying that this isn't going to work. Like what you think is going to happen here isn't going to happen, and it's because get thing actually like is not comparable to 1. So that's just not going to work. And then with Flow, you get something similar. You get kind of like, hey, I can't really compare these two things together because this is a Boolean and this is a number. So like JavaScript's like, oh, no, it's fine. I'll make it work. But like, please don't trust that. Remember, JavaScript is your friend even when you don't really want it to be. So, and then something like Reason, the VS Code integration with Reason, it actually, you can see this isn't actually part of the code. This is kind of like a little bit of UI adjustments, and it will show you the type definitions of what your function is doing in line as you type them, which is just a really amazing tool. It's kind of magical. So if you could improve how your team works and you could lower the number of shipped bugs, then that's a win for everybody. It's a win for you, it's a win for your team, it's a win for your customers, and it's a win for your sanity because you don't have to worry about late night bug reports and you can just kind of go back to enjoy writing code. So then it's a question of like, which static types should I use? Should I use Flow, or should I use TypeScript, or Reason, or some other thing? So I'm going to talk about TypeScript first, and that is what all of the Apollo projects are written with. That was a decision that we made 2 years ago when the Flow ecosystem was much younger, but I still think it's a decision that we would make today. They're both really great, and I don't want to like push one way or the other, but we do use TypeScript, and we really love it, and we've seen a ton of benefits from it. So TypeScript is a superset of JavaScript, and that means that it is JavaScript, and then it's a little bit more features on top of it that the native language doesn't provide. So in this case, types. And it just compiles down into vanilla JavaScript. Instead of writing .js files, you write .ts, or if you're using React, .tsx, so that it can go ahead and like make that, instead of using Babel, use TypeScript. And luckily, there's talk about Babel right before this, so now you know. So adding TypeScript is pretty easy. For the most part, it requires that your entire app is written in TypeScript, but don't let that scare you because you can do it without that. And there's an incredibly large public set of definitions for TypeScript. So essentially, if you're using anything from NPM, there's a good chance there's already a TypeScript definition for it, and you can just use it. And I've seen a lot of times where just by doing that, you start to catch bugs because you didn't realize how that library was expecting your code to be used with it. And that's really powerful. And then you just write types in line in the code, and I'll kind of like show you what that looks like. So why would you choose TypeScript? Well, it's development ready. With VS Code, with all the libraries, and with kind of the great tooling and documentation around it, you can get started with it today. You're not going to be an early adopter with it. You'll be able to just go in and use it, and a lot of massive projects use it. And it's production safe. The code compiles great, it runs excellent, and you don't have to worry about any kind of weird edge case of how TypeScript thinks JavaScript should work, but it doesn't actually. Okay, and then you have Flow, which is actually this logo over here. This is GraphQL, and this is me being really excited because I actually really love Flow. So why would you use Flow? So Flow actually works on top of existing JavaScript files, and then you write your type definitions in that, and then either using Babel, or you can actually write it in commented out portions of your code. You can tell Flow what's going on. So Flow is pretty cool in the sense that you can take your existing JavaScript file, and if you have no build step, you can just write the type definitions in a comment, and then Flow can read it. So it's really easy to kind of incrementally add. And because it's just JavaScript to JavaScript, you can add Flow to one file, and then later add it to another one, and then add to another one. So you can kind of focus on the really, like that buggy part of your app that you don't know why is buggy. Start adding Flow there, and you start to get some benefits from it. So adding Flow is pretty easy. This is a pretty easy incremental adoption. If you're using Babel, it's super easy, and then you just run Flow, and it kind of just magically works. And then Flow has its own set of exterior definitions called Flow typed. They're not as robust as TypeScript, but they're getting a lot better, and it's definitely something the Flow team is actively working on. So why Flow? Well, Flow, unlike TypeScript, does a lot of inference in that it's going to try and figure out what you meant before you actually tell it what you meant. Whereas TypeScript's like, no, I trust you, tell me what these types are, and then I'll make sure it works for you. Flow tries to work it out on its own. And so that can help you with a lot of bugs that you didn't think that were going to happen. And it's pretty easy to get started with. So let's take GraphQL and let's move it into our type system. So GraphQL is something called strongly typed, and then we're going to make it statically typed in our app. So this is from the original announcement of GraphQL in 2015. And GraphQL is strongly typed. Given a query, tooling can ensure that the query is both syntactically correct and valid within the GraphQL type system before execution. So what does that mean? Well, it means that GraphQL is awesome. You just stop there. That's all you need to know. So what GraphQL will do is when you build your server, you have to tell the client, this is the shape that the data is going to be present in. It's either going to be like a Boolean or an integer, or it could be there or it could not be there. And then the tooling can take advantage of that because it can ask GraphQL with an introspection query, what does my data shape actually look like? What is my server offering here? And different projects can actually take advantage of that. One of which, if you use Relay, the Relay compiler will generate Flow types for you if you use Relay Modern out of the box. So you give it your schema, and then it will generate all the Flow types based off of what your schema is. So as you write queries in your app, the Relay compiler will generate those corresponding Flow types for you. And then we have a project called apollo-codegen, which works for TypeScript, Flow, Scala, Swift, and I think that's it right now, but we're working on adding Reason in a few more languages. So it does the same thing that the Relay compiler does. It will take a look at all of your queries in your app, and it'll take a look at your schema, and it'll generate these types based off of what your schema could actually look like, which is really, really awesome. And then if you use ESLint, there's also an ESLint GraphQL plugin. And so this is like an invalid query. This doesn't actually exist on my server, and ESLint will catch it for me and give me some intelligence of like, hey, this doesn't actually work, so you can run it, but good luck. It's just going to break. All right, so let's actually do this. So this is going to be a little bit hard to see, but I'll kind of walk through it more in depth. So this is a really simple little like React Apollo component. So I have my query. This is using the Star Wars schema, which is kind of like the hello world of GraphQL. If you haven't checked it out, it's worth checking out. Also, if you like Star Wars, it's worth checking out. So I take this little query, and then I'm going to use the GraphQL function from React Apollo to allow it to be bound to React. And then I'm going to wrap it with a component. So this is a high order component. And then I'm going to say, like, hey, if it's loading, then like tell people it's loading. If there's an error, then we'll just say error. And then I'm going to, like, once I get the data back, then let's print out a list of all the friends of this hero. So we want the hero's name and then all of their friends. So I can take a look and I can say, okay, well, cool. I can tell you, because I know my schema. Like, honestly, I know it. Don't worry about it. So there's this hero, right? It's going to have a name, and it's going to have some friends, which are also heroes. And my response is just going to come in as hero. So I can add that in, and then with React Apollo, you can tell GraphQL what your response is going to look like, and then it will type check for you in your render function. So if you try and access something like hero.firstname, then TypeScript will give you a warning and actually stop your build from working because that doesn't exist, and so that code's never going to work. And it all does this because you've told React Apollo what these types look like. You can also type how the input looks. So it's like adding a required prop type, right? But it does it using TypeScript or Flow. And so you can say, like, all right, this component will always need an episode that is a string. And so you tell that to the high order component, and then somewhere else in your app, when you actually put that in the tree, TypeScript will tell you, like, oh, you're missing a prop, so this isn't going to work. So like this could be 10, 100, 30 files over, and TypeScript will still give you a warning saying, like, oh, your app isn't going to work the way you think it's going to work, which is really, really powerful. And then React Apollo does a few things, like it allows you to create new props based off of the response of your query. And so you can even add those types as well. So these are like the wrap props. And then if you try and do something like, if you want to create an isHero, and you're trying to access isHero, but it doesn't actually, your server never returns anything called isHero. So again, this could be many files over. TypeScript or Flow will help you and tell you, like, that's not going to work, like it's going to break for you. So this is actually, let's see, right here. This is actually potentially very buggy code. And the reason why is because with GraphQL, you have the idea of a nullable response, meaning like, hey, this may not show up. I know every time you have ever queried it, it has, but as a server developer, I'm telling you, like, it could not happen. It could not show up. But as a client developer, you're just hitting this data, and you're like, oh, yeah, it's always there. So I'm just going to assume it's there. So here I just like mapped over all of the friends without realizing that friends could not actually be there. I could have no friends, which would be really sad, but you're my friends, right? All right, so I have friends. So what you can do is you can use apollo-codegen. So this is how you use apollo-codegen. You go and you get your schema, and then you generate all of these, in this case it's TypeScript, and it will add those to your project, and it'll like give you actual files. So then this is what it generates. So it's kind of, again, it's kind of a little bit hard to see here, but this is a really big type definition of that query. And you can see all these nulls. So these are all the places where I didn't realize that my data could not exist, and my app was actually going to be broken for some edge case users. So those are like those 15% of bugs that instead of you writing all these types out, you just get for free because GraphQL and Apollo makes all this really easy to work with together. So using GraphQL and these statically typed systems, you can have better development experiences. You can know what's going on, especially for larger teams. You can build better products, and you can ship less codes. And all of it is available today using the existing tools with Apollo and React Apollo. And if you're able to, if you want to learn more about GraphQL or about how this stuff works, we are having a conference in San Francisco in a couple weeks, and you can use this React Brazil as the code and get 25% off tickets if you're able to go. So hopefully you'll be able to make it there, and that's just for everyone here. So thank you.
Thank you, James.